Types of numbers. Broadly, numbers can be said to be of two types. 1. Real numbers. 2. Imaginary numbers. Now, we'll start with the first one. 1. Real number. Real number is a number that can be expressed on the number line. In other words, all real numbers can be felt or experienced in the real world. The symbol for real number is, we represent real number as this R, as R. Real numbers are just numbers like 1 minus 3.41, 12.38, 3/4, pi, square root of 2, 198, minus 7.411, etc. In fact, nearly any number you think of is a real number. Any number you think of is a real number. Now, which number is not a real number? Any number you have in a square root and it is negative. So, square root of negative number is not a real number. This is imaginary number, in which we are going to discuss in another video. But for now, we are talking about real number. Now, if I have square root of minus 8, this is not a real number. It is an imaginary number. Apart from this imaginary number, which is second type of number, any other number you think of is a real number. Now, what are the types of real number? Now, let's say types of real number. Or the point, real number is a number that can be expressed on the number line. See number line. Let me emphasize on that. So any number you can represent on number line. So if here is 0, in your graph you can have 1, 2, 3, as in 4. All the numbers to the right are plus. So it will continue to plus infinity. Now to the left you have minus 1, minus 2, minus 3. It will continue to minus infinity. So any number between this minus 1 to 2, we have decimals like minus 1.7, minus 1.8, minus 1.001. Any number that is minus 1 point something is still between minus 1 and minus 2. So that means it can be fraction, it can be decimal, anything. It can be pi. Pi is 3.142, so we can locate pi anywhere around there. That means any number you can express on number line is a real number, to just emphasize on that part. Now, types of real number. Types of real number. Number 1, let's take natural number. So types of real number. Number 1, rational number. All the counting numbers are called natural numbers. Any numbers, that is, as we count 1, 2, 3. So all counting numbers are natural numbers. The sets of natural numbers are represented by n. We represent the set of natural number as n. So if you see n, so you should know this is a set of natural number. So that means I can say the set n are 1, 2, 3, 4, 5, dot, dot, dot. So anytime you see dot, dot, dots in your math, it means the number continue till infinity. So all these numbers are counting number. So if they say count, you say 1, 2, 3. So apart from 0, 0 is not a natural number. So the smallest natural number or the lowest natural number is 1. So the lowest natural number is 1. So if you want to count, you say 1, 2, 3. Now the counting numbers like that, they are natural number. All numbers you can count with your fingers, they are natural numbers, and that is 1, 2, 3, like that. And the lowest natural number is 1. So natural numbers is a non-negative number. That is, they are positive numbers. The equation format of natural numbers is given by equation format, that is an is an minus 1 plus 1. So where a1 is equal to 1, that is the lowest natural number, and a1 is the lowest. So a1 is the lowest natural number, which is 1. So this is the format or the recurrence relation of representing a natural number. So now we have a formula or generalization of natural number. So take that point now. Natural numbers are counting numbers, and they are 1, 2, 3, like that. So now we have generalization of natural number. Sum of the first n natural number is given by n plus 1 divided by 2. Understand that the formula is applicable only if we are adding the number from 1, then 2, then 3, and so on. For example, if I say sum of the natural numbers, sum of the natural numbers, sum of the natural number from 1 to 50. Sum of the natural number from 1 to 50. So how can I sum? That is 1 plus 2 plus 3 plus 4 plus 5 up to 50. So how can I sum this? So sum will be equals to 50. So number is 50. 50 into 50 plus 1 divided by 2. So which is 50 times 51 divided by 2, which is 2 here 1, 2 here, 25 times 51. So if you press your calculator, so what are you going to get? So you can multiply it out or show it. So that is 51 times 25. So I'll be teaching short method to multiplication later. So 1275. So if you multiply, So that means the sum of the first 50 natural number, that is 1 to 50, is 1275. So if you add 1 plus 2 plus 3 plus 4 plus 5 up to 15, continue like that, the answer will be 1275. So that is sum of the first n natural number. So now we can have more than that. We can still have questions that can be between, but for now, since we are just solving, or we are just talking about types of numbers, then I'll just limit it here. Just know this: sum of the first n natural number is this. We are going to emphasize more as we proceed. So now, let's say, okay, let's move on. Let's move to whole number. Now I said types of real number. Number one, we pick natural number. Now, number two, whole number. Number two, whole number. Now, all counting number, that is, all the counting numbers together with 0 form the set of whole numbers. The set of these numbers is represented by W. So the set of whole number is represented by W. Thus, we can say W is equals to 0, 1, 2, 3, 4, continue. So if you involve 0, then it's a whole number. If you exclude 0, then it's natural number. Take notes. So let's move on. Number 3, integers. 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 Integers are defined as a negative counting number, that is, or a negative natural numbers. So since we know natural numbers are 1, 2, 3, the negative of all these natural numbers are -1, -2, -3. So I'll say integers are all negative natural numbers, that is -4, -3. So this dots before means the numbers, we have numbers before -4, -3, -2, -1, 0. So after 0, so let me stop here first. -1, continue. So now integers are all negative natural numbers. Which are these numbers? 0 and all positive natural numbers. 1, 2, 3, 4, continue. So all these are integers, that is negative natural numbers, 0 and positive natural numbers. So everything here are integer. Note, integer do not include decimal. So as you cannot see decimal like 4.3 or 1.2, there is nothing like decimal here. So integers do not include decimals or fraction. You can have 3/4, 1/2. So it is just a whole number, that is number without fraction here. So if I say is 3/2 an integer, so you say no, because it involves a fraction. An integer can be a negative natural number, 0, and also positive natural numbers. then it cannot be a decimal and it cannot be a fraction. So if they ask you what are integers, you can say integers are all negative natural numbers, 0, and all positive natural number. That's all. And this is what you see. These are the integers apart from fractions and decimal. So the negative natural number, 0, and positive natural number are integers. Take note. Now, the set of integers are represented, or we denote it by z, that is z. We denote the set of integers as z, or you will say I. That means I can say z, the set of integers are negative natural numbers minus 2, continue, 0, and positive natural numbers, like that. So this set are set of integers. Now you can observe, you can jot this. So from beginning we started with natural number. So we said natural numbers are 1, 2, 3, 4, 5, all counting numbers. We also said whole numbers, we use W for set of whole numbers, are 0, 1, 2, 3, 4, 5, 6. And we also said integers, z, is negative natural numbers, 0, and positive natural numbers. Now clearly the set of positive integers, that is, if I say positive integers, they are this 1, 2, 3, like that. Continue. The set of positive integers and the set of natural numbers. The set of natural numbers n is included in the set of integers. So that is what I want to pass. The set of positive integers and the set of natural numbers. If you look at the numbers, you see they are the same. That means I can say the set of natural numbers, all these numbers, is included in the set of integers. Therefore, I can say natural number is a subset of z. That is, all natural numbers are inside integers. I can also say all whole numbers are inside integers. So it's a set of all integers. So we have positive and negative numbers. You already know positive numbers are +1, +2. Negative numbers are -1, -2. So we'll emphasize more on that. And that is how we have integers as -4, -3, like that. Or +1, +2, like that. Then what are the properties of 0? So I did not talk about 0. Now let me discuss 0. Since integers are positive natural number, negative natural number, and 0, and positive natural number are in the set of integers, whole number are also set of integers. But what is now 0? You can jot this, the properties of 0. 1, 0 is an integer. As you can see now, we have said sets of integers are negative natural numbers. Zero. So 0 is part of integer. So properties of 0. Number 1, jot that 0 is an integer. Number 2, 0 is an even integer. What are even numbers? First, even numbers are numbers that you can divide by 2 without remainder. Now, for example, 4 is an even number. So 4 divided by 2 is what? 2. So that means 2 can divide 4 without remainder. 8 divided by 2 is what? 4. That means 8 is an even number. 7 divided by 2 is what? 3.5. Because it will have decimal, then 7 is not an even number. And 0 divided by any number is 0. 0 divided by anything, in short. 0 divided by anything is equals to 0, apart from 0 divided by 0. So if the denominator is not 0, then any other thing apart from 0, the answer will be 0. So that means 0 is an even integer, because properties of an even number is that any number you divide by 2 and it does not have remainder is an even number. That means 0 divided by 2 will give me 0, so no remainder. That means 0 is an even integer. So 0 is neither. Number 3, 0 is neither positive nor negative integer, the only one of this kind. That is, you can't say 0, I can't say plus 0, and I can't say minus 0. 0 is 0. So 0 is neither a positive nor negative integer. Take notes. Number 4, 0 is divisible by every integer except 0 itself. I've explained that. That is, 0 divided by anything is 0, apart from 0 divided by 0. Take notes. So apart from 0 divided by 0, 0 is divisible by every integer, any other number. So if we say integer, you should know what we mean by now. If we say natural number, you should know what we mean. If we say whole number, you should know what we mean. Now, multiplication. Multiplication. If I say minus times minus, it will give me plus. Take notes. Negative times negative will give you plus. Positive times positive will also give us plus. So that means the same sign, if you multiply it together, you get plus. But different sign, minus times plus, will give us minus. Plus times minus will give us minus. So we need this almost every time. Study it. Minus times minus is plus. Plus times plus is plus. Minus times plus is minus. Plus times minus is minus. So we've talked about even, but let's take it as a heading. Now, even number. An even number is an integer that is evenly divisible by 2. That is divisible by 2 without a remainder. For example, 4, 6, 8, 0, minus 10, minus 20, minus 30. All these are even numbers. Why? Because if you divide everything here by 2, it will not have remainder. So that is an even number. An even number is an integer of the form. So if I want to represent even number, I will represent it as 2k. I'm using k, so k can be any integer. K is an integer, meaning k can be any number that is an integer. For example, what do we say integer means? Integer can be negative number, 0, or positive number. If I have 0.413, this is not an integer because it's decimal. 3/4, this is not an integer because it's decimal. So that means if I say even numbers, I can represent even numbers as 2k. So where k is an integer. So meaning 2 times any number integer. For example, if I say 2 times minus 2 is minus 4. 2 times 10 is 20. 2 times 15 is 30. That means if you multiply 2, any number, by 2, it will be an even number. So the general form of even number is n is equals to 2k. I'm using k here. It can be anything. I can say 2p, any alphabet. What I want to derive out is that 2 is outside. So even number will be divisible by 2 every time. Now, what of odd number? Odd number. An odd number is an integer that is not evenly divisible by 2. Odd number is an integer that is not evenly divisible by 2. That is 7 divided by 2 is 3.5. 21 divided by 2 is 10.5. Any number that you divide by 2 and it will have remainder. Or 7 divided by 2. How many 2 can you see in 7? That is 3, remainder 1. 21 divided by 2. How many 2 can you see in 21? 10, remainder 1. 15 divided by 2. How many 2 can you see in 15? 7, remainder 1. So that means any number you divide by 2 and it will leave a remainder is not an even number but odd number. So odd numbers are numbers that cannot be divided by 2 without remainder. Now, how can we now represent odd number just like even number? Now, I said even number can be 2k. Then odd number will be 2k plus 1. It will leave remainder 1. You see, all the examples I use, when I divide by 2, it's giving us remainder 1. So that means even number, odd numbers will leave remainder 1. So this is how we represent odd numbers. And this is how we represent even numbers generally. So now we have notation of repeating decimals. Notation of repeating decimal before we can talk about rational or irrational. Remember, we are still on types of real numbers. Number 1, what I mentioned is that types of real number. Number 1, I said natural numbers. Number 2, I said whole number. Number 3, integers. So it's under integers that we are doing all other things. So now, before we proceed, let us see how we can represent a decimal number. So repeating decimal, in short, repeating decimal like 0.33333, meaning it's continuous. We can represent it as 0.3 and put bar on it. So this bar shows that we repeat 3 several times. That is it. Now look at another one. 0.166666. Now what are we repeating here? 0.16. That means we are repeating 6. The bar does not affect 1. It's only affecting 6 because it's 6 that we repeat several times here. Now look at this. 0.09090909, continue. Now to represent this in decimal notation, you will say this is 09, put bar on it to show that 090909 we repeat it. So 09 is repeating like that. Look at this. 3.1428571 or 1428571 428571. Continue like that. Now what are we repeating here? This will be 3.142857. So put bar on all this. That means all these are repeating 142857, 142857, like that. So that is how we can represent a decimal in short form, especially repeating decimal like this. So now let's proceed with our types of number. So now types of real number. So now we have number 4. Remember, number 1 natural number, number 2 whole number, number 3 integer. Then number 4 of types of real number is rational number. Rational number. A rational number is a number that can be expressed as a fraction. What is a fraction? Any number that has numerator and denominator. This one will be numerator and this is denominator. So any number with numerator and denominator is a fraction. So a rational number is a number that can be expressed as a fraction, a over b, where a and b are integers. So and b cannot be equal to 0, meaning this number here cannot be 0. So any number you can express as a over b in terms of fraction like this, and where this one is not 0, is a rational number. So you can now note, now you can jot it. If they ask you what is a rational number, a rational number is a number that can be expressed as a fraction, a over b, where a and b are integers and b is not equal to 0. So the term rational comes from the word ratio. The term rational comes from the word ratio because the rational number are the ones that can be written in the format of ratio. If I have 3:5, it's the same thing as 3 divided by 5, and this is a rational number because we can express it as a fraction. Now a rational number can be written as terminating, ending, or repeating decimal, such as terminating like 0.5, meaning the decimal terminates. Ending, that is 6, is also terminate, or repeating decimal, such like 0.3333, like continue. All these ones are rational number. Rational numbers can be positive or negative. So all integers and all fractions are rational numbers. That is, natural number is inside whole number. Whole number is inside integer, and integer is inside rational number. Now we represent rational number as q, the letter q. So this one that I said is inside, it means subset in mathematical symbol. Natural number is a subset of whole number, meaning natural number is inside whole number. Whole numbers are 0, 1, 2, 3, 4. Continue. Why natural numbers are only this one? We've talked about that. So now we can see examples of numbers, or how we can change a rational number to fraction. How we can test a repeating number, maybe it's a fraction or not. We need to do that. So let me clear this. By now you have seen all natural numbers, all whole numbers, all integers, everything a rational number. So let's say properties of rational numbers. Properties of rational numbers. So every rational number can be expressed as a terminating decimal or as a repeating decimal. If you check my video on how to change a decimal number to fraction, so I've done the terminating decimal. So here I will do the non-terminating decimal, but I'll still brief the terminating decimal. So every terminating decimal is a rational number. Every repeating decimal is a rational number. For example, 0.5 is a rational number. Why? Because we can change 0.5 to fraction, and 0.5 is the same thing as 5 divided by 10. That is, if you watch down my video on how to change a decimal to fraction, 0.5, I said remove the decimal points. Remove the decimal point first, so it will remain 5. Remember, 0.5 is still 5, so remove the decimal points. Then divided by, change all the numbers here, change it to 1 before decimal, and change all the numbers after decimal, change it to 0. That means 0.5 is 5 over 10. Please watch this more on how to change a decimal to fraction, but I will emphasize more on the repeating decimal. Now let's say repeating decimal. Repeating decimal like 0.3333. Continue. So if the number continues this way, now how can we change this? How can we change it to fraction? So number one, let's talk about period. I will explain this later. So let's talk about period. What is period? The recurrent part of a non-terminating decimal is called period. So all these recurring parts of the non-terminating, that is 0.333. Non-terminating means this does not stop, it continues. So now all these ones are called the period. So that is, period is the recurring part of a non-terminating decimal. Now periodicity, the number of digits in the recurring part of a decimal is called its periodicity. For example, 0.3333, like that. Now what is the periodicity of this decimal. You remember I said 0.333. I can short it as 0.3 and put bar on 3. That means the periodicity of this number is 3, because it's 3 that is repeating continuously. Now let's say 0.471471. Now if I want to short this is 0.471. Put bar on it because it's repeating. Now the periodicity of this number is 3, that is 471. So that's it. So that means 471 will repeat to eternity. So if I have 0.18181818 continue, this I can short it as 0.18. Now the numbers that is repeating here is 1 and 8. So the periodicity here is 2, meaning 2 numbers are repeating like that. That is periodicity. Now let's see how to change a repeating decimal to fraction. So let's start with the examples I'm using since 0.3333. So change 0.3333 continue to fraction. Now I want to confirm if this is a rational or not. So far is a repeating decimal, is a rational number, but how can we now change it to fraction? First, let's let x to be equal to 0.3333 continue. Let x equals to this. Then multiply both sides by 10. Multiply both sides by 10. So this will be 10s is equals to, if you multiply all this by 10, the point will move. So this will be 3.3333 continue like that. Now this is the same thing as 3 plus 0.3333 like that. You remember now I can change this decimal to this. I can split the fractional part from the whole number part. So now this will be 10x equals 3 plus x. Why x? Remember from beginning I said let s is here, let s be 0.3333. so now that I see 0.33 here, I can represent it back as s. Substitution. Collect like terms. So we have 10x minus x is equals to 3. So this will be 9s is equals to 3. Then divide both sides by 9. S is 3 over 9. So x is 1 over 3 if you divide. Now let's take this point. You don't need to solve this procedure before you can change this to fraction. Now look at this. To change 0. That means if you press calculator 1 over 3, it will give you this. So if you see question like this, what numbers are repeating here? Is 3. I have 3, 3, 3, 3. So how many numbers is repeating? How many number is repeating here? It's just one number, and that number is what? 3. Now you write that number first, divided by, now if one number is repeating, you divide by 9. That's the shortcut. Now let's use another number, so you get that concept. Now let's say 0.18181818. Continue. Let's say I want to change this number to fraction. To change this number to fraction, how many numbers are repeating here? 2. That is 1 8. We repeat it. 1 8 1 8 1 8. Any numbers that are repeating, write it first. 1 8 divided by, now the first one will be 9, the second one will be 9, so that will be divided by 99. So that means 18 divided by 99. You can reduce this. 3 in 18, 3 times 6 18. 3 in 99, 33. 3 can still go. 3 here 2, 3 here 11. That means 2 divided by 11. If you press it in your calculator, you will get this. That is how you can change a decimal, a recurring decimal to fraction. To know how to change terminating decimal to fraction, watch my video on how to change decimal to fraction. You will understand better. So now let's say we have 0.77777777 continue to fraction. Now how many numbers are repeating here? Just 1. So this will be at in 7, just 1. Change it to 9. So the numbers that are repeating is just 7. Write it first over just one number, so over 9. Now look at this. 0.145 145 145 145 continue. So how can I change this to fraction? How many numbers are repeating? 3. So this will be 145 divided by 999. That is 999. The number of numbers that are repeating will determine the number of 9s. Now look at this. 0.3434 continue. To change this, 3 4 are repeating, so I'll write 3 4 divided by 3 4. That is 2 numbers, so that will be 9 9. So that is how you can change a recurring decimal to fraction. Study it. Now we can also have different form, like let's say I want to twist one. Let's say 2.454545 continue. Now how can you change 2.4545 to fraction? Now first split this part, split it. That will be 2 plus 0.454545 continue. So this now is the same thing as this. After you split the whole number part, the integer part from the fractional part, then this can be 2 plus, now change this to fraction. That will be 45 is repeating divided by 99, because we have 4 5, 2 numbers. So 2 plus 45 divided by 99. That means you will find the LCM. So this is the same thing as 2 whole number 45 over 99, which is 243 divided by 99. So if you press this, you are going to get this result. Now what of 3.4712 continue. So how can you change this to fraction? This is 3 plus 0.4712 4712 continue. So now this will become 3 plus, now you have 4 712, repeating, divided by how many? 1 2 3 4. So 1 2 3 4, you have 9 nines and 4 nines, like that. So this is 3 whole number 4712 divided by 9999. So that is how you can change a decimal, recurring decimal to fraction. Now what if you have 0.571 571 to fraction? This will be 571 divided by 999. So that is how you can change a recurring decimal to fraction. Now let's say again, what if it's 0 point something? Let's say we want to change 0.012 we want to change this to fraction. The first thing, you have 0.0 something, as in here 0.0. So how can you clear that first? So if you have 0.0 something, multiply by 0.1 first. That means this is the same thing as 0.1 times 0.12. So anytime you have 0.0 to multiply by 0.1, so that will be 0.1 times this. So that is the same. That is how you can change anything 0 point. Now this is the same thing as 0.1 times 12 divided by 99. How? 1 2. We are repeating 1 2. So that will be 1 2 over 9, like that. So that is how you can change. And this one is the same thing as 1 over 10 times 12 over 99. So which is the same thing as 12 over 990. We can reduce it more. 2 divided by 165. So 2 divided by 165 will give you 0.012, like that. So now let's say density property of rational number. So density property of rational number. Density property of rational number. So from this part, we learn that between any two rational numbers, there exists infinite of rational numbers. For example, if I say find two rational number, find two rational numbers between 3 over 4 and 2 over 7. So find two rational numbers between 3 over 4 and 2 over 7. We said between any two rational numbers, there are infinite number of rational numbers. Now, to find any rational number you like, add this and this together first. This will be 3 over 4 plus 2 over 7. Then divide the result by 2. So this will give us LCM. Here is 28. So this will be 21 plus 8. That is, how many 4 can you see in 28? 7. 7 times 3, 21. So again, 7 in 28, 4. 4 times 2, 8. Normal LCM. Then divided by 2. That is 2 over 1. Instead of this divide, I'm using the divide. So this will becomes 29 divided by 28 times 1 over 2, which is equal to 29 divided by 56. That means this is one rational number. The same way, I'll still say 3 over 4 plus 29 over 56, everything over 2. So you plus this. So that means you can find the LCM again. So the up one will give 71 divided by 56 times 1 over 2, which is equal 71 divided by 112. That means the two rational numbers between this and this are 29 over 56, 71 over 112. We can have as many as possible, but I'm picking this as my own. But that is the techniques of finding rational numbers between any two rational number, because between any two rational number we can have infinite rational number. So if you say, so just study that. So now give 4 rational number. For example, give 4 rational number between 1 over 4 and 1 over 3. So the 4 rational numbers between 1 over 4 and 1 over 3 are, you will say, let's generalize a formula here. For inserting n rational number, you have to know this. For inserting n rational numbers between a and b, for inserting n natural number between for inserting n rational number between a and b, divide b minus a by n plus 1, and then the required natural number will be a plus b minus a over n plus 1, a plus 2 b minus a over n plus 1, a plus 3 b minus a over n plus 1, continue, plus a plus n b minus a over n plus 1. So this is like a generalized formula. Or can we try and show something here? But just note it because of time. So note that generalized formula. Let me use it for this question. Now the question is, find any 4 rational numbers lying between 1 over 4 and 1 over 3. So find any 4, or give any 4 rational numbers lying there. The first thing, I'll say a is equals to 1 over 4 and b is equals to 1 over 3 and n is equals to 4. That is, I want to give 4 rational numbers between this and this. So n is 4. A is the first number, b is the second number. So first find b minus a divided by n plus 1. So that will give us, what is b? That is 1 over 3 minus 1 over 4 divided by, that is b minus a divided by n plus 1. That is 4 plus 1. So because n is 4. So this is the same thing as, can find the LCM for the up one. That is 12. 3 in 12, 4. 4 times 1, 4. Minus 4 in 12, 3. 3 times 1, 3. So that will give me, that's the up one, everything over 5. So this is 1 over 12 divided by 5 over 1. So because 4 minus 3 is 1 over 12. So instead of this divide, I'm writing this divide. So 1 over 12 divided by 5 over 1. 1 over 12 times 1 over 5. So which is 1 over 60. Now, the 4 rational numbers. So you can now use the formula I gave you. So that means the 4 rational numbers will now be 1 over 4. So let me clear this. The 4 rational numbers are 1 over 4. So 4 rational numbers between 1 over 4 and this will be 1 over 4 plus 1 over 60. As in that result we got, comma, this result. So that is the one I'm using. I'm using this one, 1 over 60. So by dividing b minus a over this, we got 1 over 60. So it's the one I'm adding together now. So take note. So the 4 rational numbers between 1 over 4 and 1 over 3 now are 1 over 4 plus 1 over 60, 1 over 4 plus 2 over 60, 1 over 4 plus, so that's how you continue, 3 over 60, that is the generalized formula, 1 over 4 plus 4 over 60. So these are the 4 rational numbers. You can find the LCM of everything. So you will notice the LCM is 60. This will be 15 plus 1. LCM 60. So 4 and 16 again. That is 15 plus 2. LCM is 60 again. That is 15 plus 3. LCM is 60 again. That is 15 plus 4. So remember, LCM of 4 and 60 is 60. 4 in 60 is 15. So 15 times 1 is 15. 60 in 61, 1 times 1, 1. So do the same thing for others. Now, 15 plus 1, 16 over 60. 15 plus 2, 17 over 60. Plus 3, 18 over 60. Then 19 over 60. So these are the 4 rational numbers between 1 over 4 and 1 over 3. So that means between any 2 rational numbers, we can have infinite rational numbers. So take notes. Now we have irrational number. So irrational number. What are irrational numbers? Irrational numbers are numbers that they are non-repeating and they are non-terminating. They are repeating, and they are non-terminating. So if they ask you what is a irrational number, you will say they are repeating but non-terminating. So irrational number. Irrational. So they are repeating. They are repeating and what? Non-terminating. For example, if you press calculator square root of 2, press square root of 2 in your calculator, what do you notice? So you will see the square root of 2 is 1.414,213,56,237. It will continue, but you will notice that all these numbers are not repeating. It's just different throughout. So root 3 also, you follow the trend. Pi, if you press pi, the real pi is not 22/7. 22/7 is an approximate value of pi, but the real value of pi is 3.14159265359, like that. You will see they are non-repeating. You will notice now they say take pi as 3.142. If you look at it, it's approximate. So that means your 22/7 is approximate value of pi. The real pi is irrational number. Irrational numbers are those numbers that are repeating but that are non-terminating and non-repeating. Sorry. So please correct that. What is irrational numbers? Irrational numbers are numbers that are non-terminating, meaning it continues, like 1.41421356. It continues, non-terminating, and non-repeating, meaning the numbers are not repeating, just like 1.4141414141. All these ones are repeating, that is 414141. But if you look at this, it's non-repeating. So now if they ask you what is irrational number, irrational number are those numbers that are non-terminating and non-repeating. So that is irrational. Now we can test whether a number is irrational or a number is rational. We will do that in another video. But here, know the types of number. So if we are using it, you will know the terms. Thank you.